Thank you for joining us. Again, I'm Scott Kelzia. I'm product manager for Aruba's campus controller product line. Today, we have kind of a couple things that we're going to talk about. One, I'll reintroduce the 7200 series, and rather than just have you look at the slides that are up there, and well, if you can put on the slide mode, but I also have a prop, and we'll see how this works out, because as Ozer mentioned, it is kind of heavy, but I'll try to give you an introduction of the 7200 a little bit. And then Bala's going to, I'll turn it over to Bala. He'll give you a view of what our AppRF capabilities have in store for the controllers. So introducing the 7200 series, you can see up there on the screen as well. It's Aruba's third generation controller platform, and we've spent a huge amount of development effort really in making this platform perform and scale to the world's largest Wi-Fi networks. So looking at it from a physical perspective, there's three models. They all appear the same, and you can see the other two are sitting up there. The only way to really tell them apart externally is just by the label, 7210, 7220, 7240. Physically, they are identical. You can see on the front, starting over here on this side, your standard console interfaces, a mini USB for a console interface, an RJ45 console interface, USB port. Those are pretty typical for our previous generation products. Here in the middle, we have four 10 gigabit interfaces for interface connectivity. These are actually gigabit and 10 gigabit, so it works very well across a wide variety of customer deployments, depending on the interface speeds and needs that they have, SFPs or SFP pluses. Oh, right next to that, you have a pair of ports. These are dual media ports, so an SFP as well as an RJ45. These can also be used for interface connectivity. They're also used for management interfaces, so out-of-band management. Can also be used as HA. So as I pair multiple mobility controllers together for redundancy purposes or load sharing purposes, I can use these HA ports to build 1+1 redundant controller clusters or N+1 redundant controller clusters. Moving over a little bit more, we have an expansion slot. Currently not in use for the 7200 series, but future development plans will utilize this slot for future capabilities. Now on the platform on the back, again, all three are the same. Flip it around here, you got a field replaceable fan tray, 4 fans sitting there. Of course, variable speed fans. One of the fans fails, the others can take on the load, keep the unit cool indefinitely until the unit can be swapped out. And of course, a pair of power supplies. Only one power supply is shown in this particular model, of course, but the power supply there for redundancy reasons. So built as a very highly available type of platform. Now, the difference between the three models, set that down for a second. The difference between the three models is really internally, and of course you can't tell externally. They all look the same physically, as I mentioned. But internally, they all have a multi-core hyper-threaded CPU architecture. On the high end, we're looking at a CPU that has 8 cores with 4 CPUs each, so 32 virtual CPUs within the single platform. Can you advance me one more slide, will you? So that coupled with a solid-state storage architecture, we have 8 gig of SD-RAM, we have 8 gig of eUSB flash memory, it's in there as well. We use NOR memory, of course, for boot capabilities. But this gives us the ability to really scale the platform. So from our previous generation platforms, we scale to about 4 times the number of access points. Over 2,000 access points can be supported by a single 7200 mobility controller. And we're very proud of that. And if you put that into some context, what does that mean with 2,000 APs? We actually figured it out. So if you take 2,000 APs, and I apologize, this is a little bit of marketing, that comes a little bit from my background, but 2,000 APs, and you look at about 3,200 square feet, I think is the number that we use on an average for an access point. You actually have the coverage area that can cover the entire Pentagon. That's all 5 floors of the Pentagon. So there you go, that's one of the largest buildings out there in the world. And some interesting points to note is within each one of the slices, the 5 slices of the Pentagon, you can fit a single national Capitol building. And that area of the Pentagon is equivalent to 3 Empire State Buildings. So this is a huge coverage area. Now, of course, we know wireless from a coverage is important, but also from a capacity is also very important. So we've quadrupled the number of devices that can be supported. 32,000 devices within a single 7200 series controller. And of course, performance becomes important. We've increased, I showed you the interfaces on there, 4 by 10 gig. We have an encryption engine that we can offload the encryption, and we can support up to 40 gigs of encrypted throughput on the platform as well. So following all the numbers up here. VPN sessions, of course, has increased. I think it was Ozer, I can't remember if it was Kirti, was talking about having instant deployments in remote or branch office locations and using VPN to tunnel some traffic back for management purposes, or if I want to have a VPN offload for a variety of reasons, I can support 32,000 various locations through that VPN, that IPsec tunnel. Firewall sessions. All of our controllers, we've always talked about the fact that it has an integrated firewall capability, 40 gigabits of firewall. Over 2 million sessions, again, increased that by about 4x. So overall, again, as I mentioned before, this platform is really scaled for extremely large types of wireless deployments.
And one thing that I would add, so I don't know if you guys caught that, but this relates to the instant wrap controller discussion that we had. So if you distribute your data and control plane to the APs with instant, and assume that you can support, let's say, 30, 40 APs in an instant cluster, now you have the ability to, instead of deploying one controller supporting 2,000 or more APs, you're supporting one controller with VPN services that are routed, if you want to route them back, with 32,000 instant clusters. That's a lot of APs, right? So the cost of just, deploying a controller in the back end to do data forwarding for remote branch locations all of a sudden increases from 2,000 to 32,000 times X, and X can be any number of instant APs. So compared to a flex architecture, compared to our previous remote AP architecture for branch locations, it's a huge scale jump. Right? That's the real benefit. So that's where the integration happens. If I can use the controller as just as a data forwarding VPN termination, and I can distribute my control plane and data plane, then that's great. Great savings. Huge amounts of savings, actually, if you do the math.
Great, thanks, Ozer. So capacity, performance capabilities, scaling to number of devices, all important as well. But of course, the precious commodity in wireless networks is really the air itself. So with all these mobile devices out there, all the various applications that are running, one of the things that's extremely important and what we saw moving forward was the applications. And how can we identify various applications on the network, get an understanding of what users, what devices, and what applications are running, and then optimize those applications, and in some cases provide a policy, either a security policy or a quality of service policy for those applications. So that's something that we introduced along with the launch of the 7200 back in December, which was called Application RF, or AppRF for short. This is the ability for the mobility controller to fingerprint various applications on the network, and we use a variety of methods. We can use well-known destination addresses for things such as Box or Twitter or FaceTime types of applications. We can identify those on the network and essentially fingerprint them with the mobility controller, and then make a policy decision or define a policy decision for those specific types of applications. Additionally to that, if it's encrypted traffic as an example, we can use a variety of heuristics to determine what the specific application is, and again, make a policy decision on that specific type of application. So with that, I want to turn it over now to Bala, who is going to talk a little bit about Application RF and show you specifically how it works and some of the visibility capabilities that you have with Aruba's mobility controller. So Bala, sorry I didn't introduce you, so you might want to take a moment to do that.
Sure. Welcome, everyone. You have probably seen me in the last WFT3, back in the FOC lab. I've been with Aruba for almost 3.5, 4 years now on the technical marketing team. focusing on campus networks. Special welcome to Lee, actually. So I used to work, I went to school in Syracuse. We used to be in the neighboring buildings, and I used to get emails from Lee quite often saying, turn those damn rogue APs off and make sure rogue containment is turned off too. I'm here to give you guys a quick 15-minute demo of what we have introduced with AppRF. So something that we've been hearing from most of our customers are, Wi-Fi being a new technology. It's not really new, but RF scares people, right? DB and SNR, these are terminology that really scares people, and not a lot of people really understand what that really means and how does that translate into performance. Something that we've had on the Instant platform, which is a very intuitive help menu, right? Just hover over some of the terminology like PHY, some of the terminology like SNR, goodput, retries, and it basically tells you what that exactly means. For most of us here, we kind of understand what this means and what this translates to, but many of the wireless LAN administrators out there who have been managing wired networks for a long time, this is a very, very helpful tool. Now, in addition to that, this whole performance dashboard that you're seeing kind of summarizes how your network health looks like across your entire network, across all your access points, right? If you take a look at the RF dashboard, this basically breaks down things like how many clients do I have on the network? What is the PHY rate? What is the PHY capability of the network? So right now we have simulated, so this is basically running on a 7000 series controller, again, back in the POC lab, right? And we have about 4 laptops associated to an AP135. And all these laptops are 3 spatial stream cable laptops, so they can do up to 450 megs. So it rightly shows up as AHD 40 megahertz. How does the SNR look like, SNR distribution look like across my network? Looks like the SNR from all of my clients are in the 40 to 50 range, which means they are getting pretty good signal strength from the access point, and the noise floor being low, they should be able to perform well. Other important metrics that you would expect from a performance standpoint, like how does the throughput, how does the goodput of the network look like? What is the download utilization? What is the upload utilization? What is the distribution of traffic on my network? How much of the traffic is unicast and how much of the traffic is multicast? As we all know, having broadcast and multicast traffic on the network is detrimental to the overall network performance. What are the rates at which packets are being sent out to all my clients? And how does the rate distribution look like? And having lower rates means your performance is going to come down. So having higher rates means your network is healthy.
So those are showing percentages. What's your time scope?
As in
Is it instantaneous as you're looking there, or is it over a day, a week?
So this is rapid. This is instantaneous.
So if you just sit on that, it'll be changing.
It'll be changing.
percentages?
Correct.
Is there a way to get to see what has it been for the last hour?
So that's a good question. So whatever we show on the controller dashboard is real time, and Airwave, Robert walked you guys through the RF performance dashboard and the application dashboard on Airwave, which gives you a long-term historical data.
And Airwave will store the information for, how long?
What's that?
How long does Airwave will store the information for?
Up to 5 years, if you choose to do so.
You won't be working at the company anymore, so.
So you guys have all access to the same controller, so if you want to look around.
It's not working.
You can't route to it.
It's not.
I can't ping it either.
Nah, it's the same IP that's up there.
Oh, probably. So you're on the visitor network. Are you connected to Aruba Visitor? Should be working from the visitor network too.
The
Oh, so-
4.30?
4.30, yeah.
Yeah, no, it's.
Guys, use the,
Oh, the WFT forms?
how about the public IP?
This is not on the. This is on the
Yeah, let me
private.
see if I can
private
figure out the public IP.
Okay, so just to move on, in the meantime, Oza will probably try to get access to you guys to take a
Oh.
closer look at what's going on.
If you jump over to the WFD SSID, it works. It's on the
Okay.
back of your.
Yeah, that gives you,
Yeah, the WFD4 SSID works.
Just the,
Huh?
you type it the link.
Who needs internet?
So you jump to if you're on the WFD SSID, it works. Sam?
Yeah, yeah.
So WFT4 SSID should give you internet access to let me know if it does.
So moving forward, guys, some of the other parameters, as you see here, how utilized is the channel, how does the noise flow look like, all the basic RF 101 stuff, right? You get a help desk call from a client who says there's a performance issue. These are the kind of things that you would start with if it is a RF related problem. Now, jumping on to some of the other valuable information that the dashboard gives you, which starts with wireless LAN. So what are the basic 101 question? What is the wireless LAN? What are the active wireless LANs on the network? Right now we have a wireless LAN configured as SKO. We have the 4 APs connected to that particular SID. Now, how does the utilization look like on that wireless LAN? It's about 1.8 megs consistently across the given period of time. Now we just have one radio enabled on this access point, as you can see here, and we have a bunch of clients connected here. These are obviously Star Wars characters, Leia, Vader, Kenobi, and a few others. We couldn't think of something better, but so we have about 4 different users, and these are on different client types: Windows 7, OS X, all the details that you would kind of require to start. That gives you the level of visibility that you need. Again, going back to RF, the number of frames that are being sent, number of frames that are being received, retried number of frames, the drop frames. So pretty much the information that you would need some kind of a tool like OmniPeak, or you'd have to get into the CLI of the controller, type some cryptic commands, and look at the stats that does not really make sense to a lot of new wireless administrators. It's all right there on the dashboard. Now, jumping on to the access point itself, right? Again, AP1, what radio, what channel, all the basic stuff that you would look for. And there's also a very useful checklist that you can see here, right? There is a noise floor, there is channel busy information, there is interference information, and the number of clients. Now, the sign that you see here says the noise floor is not bad, which means your performance is not going to be bad, right? NEC 93 is pretty much close to white noise. Channel utilization is low, so performance is going to be good, is what it says. Assuming you have some kind of a microwave oven or some kind of a non-native 2.11 source of interference that is jamming your channel, you would expect this to be be higher, and that should tell the administrator that this could be the cause of the performance issue that clients are facing.
you earlier said that instant APs and controller APs are run the same feature set?
Oh, just for the help.
No, I mean, so can you get this from an instant AP all the same?
Yeah, instant AP also has a built-in dashboard that gives you the
Same interface,
same level of information.
Learn 2 different ones.
It looks a little different on instant,
It's pretty
at least today.
So jumping into the third piece of the puzzle, we looked at the overall RF performance summary. We looked at the wireless LAN performance, AP performance. The next is clients. As you can see, the information includes what device is the client using, what is the user role that the client belongs to, how does the client's SNR look like, the PHY rates, and all other good information, right, with respect to retried frames, drop frames, and whatnot. Now, again, you select a particular client that again brings a checklist of SNR, speed, goodput, and whatnot. So if it falls above a certain threshold, which means the performance of the client should naturally translate to being good, and below a certain threshold, that gives an administrator a clue to say, hey, go look at some of the other RF stats that we show you on the performance dashboard to see what is going on. It could be low PHY rate, or it could be retries or drop frames or whatnot. Now, the most important piece of the puzzle is, now that we know how the RF looks like, now that we know how the clients are performing, the next question is, what are the clients doing on the network? So the
Before you start, so I want to make sure that everybody has access to the dashboard. Unfortunately, there's no public IP address, but if you log into WFD4 SSID, using instructions, you should be able to get that IP and log in and do all your stuff. And there's also instructions to log in a couple of instant APs as well, for you to compare and contrast. all that good stuff.
So the PEF visibility dashboard, this came out as part of 6.2 with the 7000 series controller launch. And as you can see, this is a single point dashboard which kind of combines together who are the users, what are the devices that these users are using, what are the applications that these devices are accessing, everything into one place, right? If you take a look at, for example, Leia, let's see what Leia is using. These are all the different destinations that Leia has been visiting, right? Includes YouTube, Gmail, Amazon, Facebook. There's a lot of ad traffic. So she's probably just browsing. And what is the device that she's on the network with? It's a Windows 7 laptop. And what role does Princess Leia belong to? So she belongs to the sales role. As you can see, we also kind of aggregate all the different individual sessions that belongs to that particular user. It's not just one destination or one URL. Per se.
It's actually, I'll just quickly interject. It's kind of interesting because we have a couple customers that were actually using this in their live networks. And in one case, it's a primary school district, K through 12. And I won't mention the name of it, but we looked at a particular staff user and looked at some of the applications that they were using, and over 90% of the applications were Netflix and YouTube.
So what are some of the applications on the network? As you can see, we have kind of simulated the 4 clients that are associated to the test society here to go to random websites. There's Microsoft Link open, there's Netflix open, and whatnot, right? So as you can see, there's YouTube traffic, there's Gmail, there is Salesforce traffic, there is Facebook, of course, Dropbox, Netflix, pretty much all the apps that you can that you'd expect to see in any enterprise. Yeah.
How are you differentiating between different traffic types from within like a single app, like voice within Link versus file transfer?
Mm-hmm. So there's a bunch of different ways we do it. So the first one is obviously services, right? Services and ports. The second is the most common destinations are URLs. The third one is deep packet inspection for certain protocols like SIP, SCCP, Vocera, and all these protocols. And we also do heuristics-based traffic identification for, especially for traffic like Microsoft Link, for traffic like BitTorrent and Skype.
So how do we see how much of this Link traffic is like voice, right?
Yeah, specifically, for example, that's a good question because so far the Link integration has been based on heuristics. So we will, since it's encrypted, we'll monitor the traffic flow and we'll do a signature matching. Now Link is actually starting to do diagnostics API, and we can actually extract information from what the Link server is seeing. So if you're running the latest version of Link 2013, I think, and if you integrate that with the order control, you can actually start separating video, voice, file transfer, etc. and we'll handle that separately.
So
It's
it requires like a real-time integration with
just the Link server.
Just the Link.
Yeah, as you're running the Link server, if you're running the latest version, you can actually tell us what that information is and we will monitor it. So far, it's really signature matching, and everything that Link does shows us Link. Is that okay?
So are you talking about that's the way that the matching works today is you're using signatures?
Signature.
So the deep packet split inspection that Bala mentioned, is that actually going to be something that's a forthcoming feature?
Okay, this guy.
Yeah.
Well, the short answer is yes, as we're going to look, for example, Link is a very good example. It's an encrypted frame, so we can't really look at the data anyway. But if the Link server tells us that, hey, I opened this session for this client, and this is a file transfer or a desktop share instead of voice, that's how we classify it.
Right, so the deep packet is, I'm Rich, I'm the product manager for this. The deep packet inspection that we do today is primarily around application gateways, so they're actually doing data inspection of traffic. Having said that, we do that for critical voice and video protocols, H.223, Cisco, VoIP, SIP, Lucera, things like that. And so for those, you can see in the, I don't think we have any calls set up, but we actually have a whole voice part of the dashboard as well. It'll give you some insight into how your phone calls are going. That's the area where we do readback inspection. Today, the link is heuristics based, and we're actually the only certified vendor for Microsoft that in the WLAN that can actually accurately detect the link. Now, as you said, sorry, as Ozer said, Microsoft does have this, it's called an Insight. If you look up Link Insight, they have a new API. We're going to support that in the next version. So that we're going to get a lot of more data from Link.
And based on just heuristics, today we can differentiate between voice and video. So you can send voice out of the voice queue, high priority voice queue, send video out of the high priority video queue, obviously, and prioritize that in an environment that has a lot of contention.
So is this your own DPI, or is this licensed, or can't you really say?
Everything we're doing here is our own.
Is this just giving visibility, or can I actually create layer 7 firewall rules with this? Or am I just seeing what's passing and can't do anything about it?
So the dashboard itself is monitored. So you can see the applications. We're still working on hooking the whole thing up so that you can take direct action from something you see in the dashboard. But by writing ACLs, you can actually classify a lot of this traffic.
Yeah, so today you would go to the dashboard and you will see what's going on with Facebook. We can go to the firewall configuration and say, I want to block Facebook for these type of users. It doesn't happen within this dashboard.
Yeah.
You just go to the configuration tab. So the configuration and the visibility soon enough will be the same, so that you can just double click here and configure it right there if you want to.
So, but if you were gonna prioritize like link voice traffic with this external hook into a link server, the user has to set up the call, then it has to go to the link server, and the link server has to report back to the controller that, hey, there's a voice call running in the link application in flight now. You can now prioritize it based on, so there's like a 3-step hop for voice prioritization.
Yeah, we basically figure out the call setup. We monitor the call setup, call signaling. We know exactly when the call is established. And when the call is established, since we're stateful, we start monitoring exactly which dynamic ports are open. They get prioritized. So it happens at the time of call setup.
It's an XML API.
From the link server.
From link server.
So some of the other additional information that you can get out of this is, select a particular application, you get a list of all the users who are accessing that application. It's waiter and layer in this scenario. And other related information, as in what device it is, what wireless LAN are they associated to, what user role do they belong to. So kind of bringing the whole context into one place. Again, a lot of other stats with respect to the wireless LAN, with respect to the user role. Again, selecting one will take you to that summary page from where you can drill down into who are the users that belong to a certain user role and whatnot. Right?
Okay, so do you guys find any good use for this? I mean, so far we have shown people what the SNR is essentially, right, over the air, what's happening with Wi-Fi. This is drilled down. You can see that we're going to expand on the feature set, do more stuff. But do you think that this is useful?
Yeah.
Yeah, very good.
Yeah.
It'd be good
Application
if there
visibility is
were,
key.
and maybe there are, but suggestions, so particularly from users that don't really know better, suggestions based on, you've got 90% of these frames at 1 megabit a second, consider disabling that data rate, or consider, suggest, that's just obviously an example that's pretty common, comes to mind, but suggestions based off what monitoring is showing them.
That's a
So
good
you're
one.
saying have essentially some thresholds that are built in that will prompt the user?
Yeah,
RF
what comes
engineer
to
box,
mind is something
expert
like
rules.
what air magnet Wi-Fi analyzer, when that's doing its thing, you've got Airwise. A lot of those rules are kind of out of date, but that make suggestions based on what's being seen. I'm sure you can sort of run with that. But
And with little knobbies, you can set them where you like.
I know it's not a real fair question, but last week I got a pretty good look at Cisco 7.4. It feels just like this. You guys know what differentiates? Again, I know it's really,
I think
it just feels carbon copy, to be honest.
The biggest feature essentially that we put in is the customization of the, so for example, if you look at the Cisco's library, it's N-bar. Basically taken from the N-bar, plugged in. Currently, 7.4 does not tie into any policy definition. And it just gives you a certain amount, there's quite a bit, there's like 1,000, I think, list of apps that they can identify. But you go and say, hey, I want to add Dropbox as an app that I want to protect or that I want to ban or limit. You don't have that option because you don't have the customization. So you're limited by the NBAR library once there. So for us, any URL is an app because any URL has a mobile app associated with it that runs on a tablet or smartphone.
Yeah, but URLs can be easily spoofed.
Yeah, we
right?
discussed
I mean,
this last time.
Yeah, this is like a really core feature.
No, at the end of the day, if you want to classify a certain app in your network, and that's where the security component comes in as well, right? So you have a stateful session firewall, and you can see where the DPI goes. You can say, hey, we're classifying Facebook.com today, and somebody spoofs that, DNS address. Are we going to have security features built in? Sure thing. We're thinking about it. But I think the way to do this type of classification is give the customization ability to the end user so that you don't have to wait for the vendor to come up with another 1,000 libraries, and then you look at it and you don't have the application that you're looking for.
So to answer your question about that, what we actually do is when you're doing your outbound DNS request, we see what you're requesting, and we match that to the ACL. We take the response and put it in the ACL. So in order to spoof that, you would have to be spoofing the DNS for your infrastructure. If you do that, you can do anything you want with the current implementation. That's not the end of what we're going to do. In terms of other differences, everything that we're doing, especially on the enforcement side, is based on our concept of roles, right? So rather, it makes a lot of sense to prioritize, your certain VoIP protocols or whatever, enterprise-wide features you have at the SSID level. But in practical networks, most of our customers want to give different levels of privilege for the applications, which is something we can do with this infrastructure that's
And
different.
the biggest difference there is, hey, there's a stateful packet inspection engine that actually understands dynamic ports, that actually understands transactions, and you can protect that. You can secure that, firewall that, at the same time when you're doing the application identification. So, and that gets tied to the role itself. So instead of dealing with apps, VLANs and SSIDs, you deal with apps, users, devices, and then whatever the IP VLAN infrastructure can be. I would say that that's the biggest. Sure, just try to stay close to the microphone.
Yeah.
What was the question on link?
And you detect voice and video and other types of traffic in there.
Yeah, so, for many years we've had this voice ALG, which looks at signaling, and then you look through who's talking to who and which session is going to carry the media, and then you go open up holes in the firewall. What we did, one of the things that Link did was to turn on SIP TLS. It is running SIP signaling, so in theory, if we had visibility into the payload of the signaling session, we can look at what's going on, who's calling who, but except that that's encrypted from the client all the way to the Link server. So we now switch the game to the data path where I notice activity on the signaling session and I key off of that and start to look for interesting sessions in the data path. And we can definitely pull out. So Link with an audio video call actually sends them on two different sessions. The audio goes on one session and the video goes on another. And we can pull that apart compared to something like FaceTime, which has a single session that carries both audio and video. And we can actually pull out individual packets and say what is carrying voice and what is carrying video.
So when you look on the screen right there and it says link is 3.9 megs, what is that?
Where is it?
Or
So
is
that's
that
the
a
amount
voice
of,
call? Is that data transfer? Is that Instant message?
No, that's the amount of data that link consumed over whatever period. Is that a minute or 5 minutes? I don't understand.
Right, but if I'm an admin and I've got link supporting, link does what, voice,
Right,
chatting,
right.
file transfer, all these things, right? And I see that in my firewall, it says link. How useful is that to me?
We need to know what's the voice stream?
Well, we can probably split it up. I mean, if that's a reporting problem, it's not an identification problem.
And the API will definitely help. The API that we talked about.
Sure.
Link server tells us exactly what that item is, desktop browsing, etc. And we will start splitting that.
Because I think that's the key is you want to prioritize link voice,
Right.
but I
Not
could care
file
less
transfers.
about that file transfer because you could be circumventing policies
Right. Exactly.
like
I mean,
Dropbox or something by just sending a file.
Today we do it based on heuristics. Everything gets supported as links. So over the air, voice and video are separated, higher priority than everything else. But then the reporting happens as one big link chunk. Going forward with the API, the reporting starts separating too, and then the
So you're
So we
saying
do all the
today,
video
even with the encrypted stream, you can still tell the difference between voice style?
voice and video, that's all I said, yeah. They get higher priority. They go to the voice queue, they go to the video queue.
right.
Heuristics. They're not reported, but over the air.
Yeah. In fact, that's
good feedback though.
Well, and that's over the air, right? So what happens when that traffic hits the wire, right? So if I want to correctly QoS tag my voice packets,
Yeah.
correct.
right, what does the ACL look like if I'm gonna write it today?
Yeah, the ACL has a two-way, if you want to tag it, re-tag it. It
No, how
follows up
do I
two ways.
call it that traffic type, right? Because link voice doesn't look like an Avaya
Okay.
voice call, right?
Yeah.
So this is what happens on the downstream. Going from DSCP to WMM is a many-to-one,
Oh, yeah.
right? So many categories can be mapped into one. The problem is on the upstream. It comes in tagged as WMM, and okay, I get one tag, and from there I have 64 different possibilities. What do I do? And we have a way to map it. So you can configure a map that says, I use 46 for my voice traffic on my wired network. Anything coming in as voice, just map it in there. But the bigger problem that you have is the client actually doesn't tag these frames.
Right.
Right? When it comes over, it just comes in as best effort. Most clients don't. I mean, there are some that do. Because mostly the client, actually the driver doesn't know that this is voice and video. Nobody tells the driver that. If somebody is able to tell the driver that, then it's going to do the right thing. So the problem now becomes, okay, we are now going to tag it as voice or video because we see the sessions going that way. And then I can tag it appropriately going out towards the network. And that is a configurable thing that you can set as to whatever you use on your wired network for QoS, we can just match those settings.
When you say most clients, what do you mean by a client? Wouldn't it be Microsoft Link application needs to tag?
The application, yes and no. I mean, unfortunately, nobody tells the driver that this is voice and video. The applications are not tagged because by default, tagging is disabled in Link, and somebody needs to push a GPO into the device saying, this is the behavior I want you to adopt.
Well, that's a traditional problem with QoS on the client side, isn't it? I mean, when you've got a dedicated voice over Wi-Fi phone, it's obviously doing QoS, but when you're doing a soft phone style application on a PC.
Exactly. So it's not that the drivers don't support QoS, but somebody needs to tell them that this is a voice packet, and that's where the disconnect happens.
But you don't usually want to trust your software because me as a naughty developer, I could go in and start tagging just a
I agree.
PvP blaster with.
Oh, I agree, which is why we have the ability to rewrite and say, okay, this is coming in tagged as voice, and that's not a voice
What's the
session as far as I know.
alternative? And then you've got no upstream QoS.
You've got to do what they're working towards, which is the heuristics of trying to figure out what that is.
Well,
and
the client's
apply.
already transmitted. the
Correct.
file, no?
So that battle is lost, and we can only correct it once it hits the controller or the access point, right? I can't do anything. If you want to create mischief on the client side, you can, but there are other ways to create mischief, which is just blast the channel, and you can cause bigger mischief in there, right? But once it crosses over the wireless link and hits the access point or the controller, then we can look at it and say, nah, you were sending it as voice, and that doesn't match what I know, so I'm going to rewrite it. Does that make sense?
Yep.
But if the bigger problem is, then for the audio-video session, if the client doesn't tag it, then the application isn't getting the QoS in one direction, but we
And that's
can
a
always
definite
fix it in
thing,
the
that
other.
like what you're saying is a possibility. Yeah, there could be apps that do it, but it's a definite issue that you're not getting that quality of
Is it
service on
really?
the upload.
I mean, have you really seen it as an issue somewhere where if they're running Jabber or Link or something and it just,
No.
I mean, that's the thing is, I mean, we've been to a few customer sites where they don't tag anything to your data network that
Well,
has standard.
that's one of the reasons why we had to go in and say, okay, it's not just about tagging that is sufficient. I have to now go in and say I need to protect the voice and video traffic when they are left untagged coming in. So we kind of throttle the best effort and background traffic down, so you create enough capacity so the guys get the. I mean, even within a client, it's hard to do because you could run your desktop share and those packets would get in front of the voice packets.
Yeah.
But at least across clients and the AP, we kind of throttle this thing down so that you create enough capacity that you will get the QoS even though the client is not
How do
tagging
you
it.
do that technically? I mean,
How do we do that technically?
If they're not coming in with a WMM tag already,
Right.
do you just do it heuristically because you think that they're gonna be, it's a voice frame?
Well, I know how much capacity they need because I know the capacity requirements of that link call. Is it an audio only call? Is it audio video? I know that, okay, an audio only call is about 200 kilobits a second. If you throw in video in there, it adds another 600 kilobits a second to the video. Then I can, fortunately, most applications are running on TCP. So if I control one side, the other side will get controlled automatically. So you're effectively trying to manage offer load at layer 4 so that it creates enough airtime at layer 2. Does that make sense?
Mm-hmm.
Session awareness, I guess, right? Fundamentally, if you don't have session awareness, you can't really figure out the packet. But once you know one direction, you know the reverse direction.
Right.
If you're session aware, so that's fundamentally.
Do we have enough time to see what a firewall rule looks like for that? Like if we wanted to prioritize link voice and we wanted to rewrite it and retag it to EF on the wire or something like that?
Right. The firewall rule is split separately. The link firewall rule is going to say media classify. I mean, that actually is a rule on the signaling session. So this is something most people don't make the connection, right? So let me go backwards. You have a signaling session. You're going to describe that and say that I want to attach a media classify rule to this signaling session. All that means is that you're not trying to classify the signaling session. You're looking for activity in there and looking for interesting stuff elsewhere based off of that trigger there, right? And then on the data path, we have rules that say on the WMM side saying how do I want you to go from voice into DSCP, and that's a separate rule. So they're not tied to the same place, but you got to kind of configure it in two different places.
Can we see it?
Yeah, I don't know if.
Or do we have time? I mean, I don't want to hide you. If anybody else wants to.
Yeah, we
if
can
you
go
want,
in
I can
5
do it
minutes and
offline
then
as
we'll
well.
take a break. Paul, if you want. I think this laptop also has access to it, yeah? There we go. All it is a browser. So, guys, after this, we're gonna take a 5-minute break. We have beer, cookies. What else?
Drinks.
That's it?
Coffee,
Ice
water,
cream.
Ice cream, if you guys wanna go for the second round. So,
different
it's
forms of sugar.
outside. Grab it, come back, we're gonna do a little bit of instant discussion. Hopefully we'll have some time to do some roadmap items with you guys as well after the cameras are off. But let's see how the day goes.
The media
I know that you guys have hard stuff at 5.
That and then you got to go to the WMSSID profile and show the.
You wanna explain?
Yeah, so this is the, now we're saying, is there a source any, so we're saying that if it's, sorry. So this says anything with SIP TLS, I'm going to attach a classify media, which is the one here.
Sure.
Right? That just says that this is the key for you to now look for activity on this session to go trigger off of that and look for, because otherwise you can pull out these frames if I look at every single packet and search for them, but that isn't scalable, right? The way we scale is that we know that okay, activity on the media sessions are going to be keyed off of some signaling activity there, so let me look for that and then start to look for interesting media sessions. So that's what that guy does, saying that, okay, you're going to look for, this is a session that's going to trigger the search for interesting media sessions in the data path. And then you have to go into the SSID profile and say, this is how I want you to map WMM tags towards a network. And you can actually specify multiple tags in the same thing. No, before you go even in there, sorry, go back, sorry, Bala. Yeah. No, not the SSID, the ACL there. Okay, now that you're here, just show it. WMM is not even enabled.
WMM, right?
You're looking for the DACB mapping?
Yeah.
Yeah, this one here. So you can go in and specify a list of DSCPs. The upstream is a little harder, so we take the first one and use it for the upstream, but on the downstream, many DSCPs can map into voice, video, and so on. But this is actually overridden because the incoming frame could be untagged, but we've looked at other things and classified that session as carrying real-time traffic. Then we're going to use other information for the link sessions, right? Chances are the incoming packet is untagged because a one-to-one call in link goes direct between. It doesn't go through the server. It's a peer-to-peer session. And if either side is not tagging, when we get the frame, the incoming frame is untagged, but we've already classified that as real time, as a link session, and then we're going to override that DSCP. This is, on the way back, we can look at it as, okay, yes, I classified this session as DSCP. I'm going to use this tag. But you can also go back to the media classify thing and set a DSCP in there that can be applied to the media session. But that is a little tricky because there's only one tag that you can specify in that ACL, but you're going to get packets that belong to two different types of traffic, voice or video. Does that make sense? I mean, this is where you're going to control how it gets tagged as you pump it back into the network. And on the incoming thing, most of the time we see that packets are coming in untagged, and we are the ones that are going to attach, because the more important QoS is on the wireless side. And before we send it down to the EP, we can retag it.